Hi everybody, this is Mr. Wright, and I just want to show you how to do the coefficient of friction lab number 2 for the AP problems here. And also this goes along with the AP friction problems that you have, which are number 53 and 47 on page 114. So anyway, on the coefficient of friction lab, if you remember, you had to figure out the coefficient of friction on the first lab by taking the friction force and dividing it by the normal force. And the friction force you actually pull it at a constant speed because the force that would take to pull it had to equal the force going backwards, which was due to friction. So the pull force minus the friction force equaled 0. And so therefore you go at a constant speed. And the normal force was the weight on a flat surface. And that's on the other side, on part 1, you got all of these coefficient of frictions, and that's what we're going to relate to when we get back. Now on part 2, let's just say on number 1, I'm going to make this up. I'm making this up. Do not put this on your sheets. Let's just say the weight of the object was 10 newtons. Well, that is not the normal force because now on this particular one, you actually have a ramp. And this ramp is at a 45-degree angle, which I don't think I'm making this at a good 45-degree angle. This is a 45-degree angle right here. And your block sits somewhere on the ramp like this. This is your block. And so that 10 newtons of force is actually acting straight down like this. So this is your force of gravity, which in this case was 10 newtons. That goes straight down. Well, that 10 newtons of force gets divided up. First of all, the road has to push against a certain amount of it, and that's what we call the normal force, which acts up. Now I'm drawing it acting down because the road's going to push up against it, but the component of gravity that is the normal force is going to be this one right here. And then you also have part of that force that makes it, that one component of gravity that actually makes it want to slide downhill. So I'm going to call that Fs. If you now notice, you now have a right triangle here. Okay? With the force of gravity, this black component here being my hypotenuse, the normal force is now my adjacent side. Okay? The sliding force is now my opposite side. Once again, gravity is my hypotenuse, which I'll just put H there. Okay? That's 10 newtons. Well, if this is 45 degrees right here, then that means this must be 45 degrees, and that means this must also be 45 degrees. I'm going to put a little 45 right there. And so on number 2, it says to calculate the normal force on the ramp. Well, the normal force is going to be, once again, that red side or the adjacent side. And so if you take, to find the adjacent side when you know the hypotenuse, you can simply take the cosine of the 45-degree angle times the hypotenuse, which in this case is 10 newtons. And so that's going to end up giving you somewhere around 7.1. 7.17 newtons. Right? In number 3, it then tells you, it says, using the normal force from number 2 and the coefficient of friction from lab number 1, so that's this up here, okay, you have to calculate what the friction force is going to be. So in number 3, I'm going to calculate the friction force by using the formula called friction is fun. I'm going to take the coefficient of friction and multiply it by the normal force. Well, let's just pretend that the coefficient of friction that I got in from the other side, I'm going to use for probably for sandpaper or the piece of rubber. Let's just say it was 0.5, okay? Well, I'm going to put in the 0.5 down here that I used from part 1 times the normal force of 7.17. And so that's going to be somewhere in the general vicinity of about 3.58-ish, maybe 5.85, something like that, okay? And so that's going to give you the friction force in newtons. Okay. On number 4, it says using the weight from number 1, calculate the sliding force. Well, your sliding force is the opposite side, so now instead of using the cosine, I'm going to say that the sliding force is going to be the sine of 45 times 10 newtons from gravity. Because part of that gravity got divided up into sliding force. And that's 7.17 newtons as well. Okay. In number 5, it says to predict the force that the scale must use to pull the block up the ramp. Well, the scale has to push up. So I'm going to call this the force that you have to pull up with. You're going to pull against two things. Well, I'll tell you what, hold on, let me do it this way. Well, I can do it this way, sure. You're going to pull against gravity. I don't know why I say gravity. You're pulling against friction, which is going to be acting against you. And you're going to be pulling against the sliding force. Boy, I'm just out of it right now. So what we have to do is we have to take our answer to number 3 and number 4 and add them together. And then that would end up getting the pull force that I'm going to need. So the friction force here was 3.585 newtons. Okay. And the sliding force was 7.17. So you add those two things together, and you get somewhere around 8.75 newtons. Well, in number 6, what you simply did in the lab, you simply pulled the scales out, pull the blocks, pull block up the ramp, and you get an actual reading. So that's going to be your actual reading there. And then in number 7, you compare the actual with the lab value, and you see how close you get using actual minus lab value divided by actual times 100. Okay? So that's how you do the lab. Hope you have a great day. Love you.